Hello everyone, we are pleased to present the current progress of our ANRF funded research project titled Development of Efficient Cooling Techniques for High Power EV Electronics. This research is being carried out at the Indian Institute of Technology Mandi under the guidance of our principal investigators Dr. Moumita Das and Dr. Sarthak Nag. Modern electric vehicles rely on compact power electronics converter to efficiently control and transfer electrical energy. Although these converters are highly efficient, they generate a considerable amount of heat while operating. If this heat is not removed effectively, the electronics components experience higher temperatures, which can reduce efficiency, shorten their lifespan, and even lead to system failure. Therefore, efficient thermal management is essential for ensuring safe operation, improving energy efficiency, and increasing the durability of electric vehicles. The main objectives of these particular projects are to analyze the GaN-based power electronics converters using ANSYS iSpec, design the heat sink for GaN-based power electronic systems, develop experimental facility, optimize the design of this heat sink, and ensure reliability for long-term support of power electronic systems in next generation EV and other applications. So the progress are shown in this particular slide. First, we developed detailed thermal model of GaN-based power electronics converter using ANSYS iSpec. Next, we investigate different heatsink geometrics and airflow conditions to identify cooling configurations that provide better heat dissipation. At the same time, we are developing a dedicated experimental platform that allow us to validate our simulation results under controlled laboratory conditions. Finally, our goal is to establish an optimized cooling strategy that can improve reliability while reducing operating temperature and energy losses in future electric vehicle power electronics. As it is shown here, the experimental facility which are developed in the laboratory. The first part is the copper block, which is for testing of the power electronic system, and the bottom part where the power electronic system is developed by using GaN devices in the laboratory for EV charging applications. So different components used in this particular work are shown here: copper block, heating elements, thermocouples, DC power supply, heat sinks, and cooling arrangement. This experimental facility will help us to validate simulation results, understand real-world thermal behavior, and identify the best cooling solutions for GaN-based applications. The simulation results and the key findings are shown here. We first developed a detailed three-dimensional thermal model of the GaN-based power converter using ANSYS iSpec. Using this model, we evaluated different heatsink configurations, including plate heatsinks, cylindrical pin-fin heatsinks, and conical pin-fin heatsinks. We also studied different airflow direction and compared both top and bottom mounted cooling arrangements, which is shown here in this particular slide. Now, coming to the science behind this particular work. The problem which exists in the power electronic system for the next generation power devices are presence of high temperature, which can reduce the efficiency, lifespan, and there is a risk of failure. So that is why we provided a solution where heat sink plays important role for taking out heat from the system. Heat sink is general solution for power electronic system, but this advanced devices causes the problem of the space. So that is why we are providing advanced cooling solution which doesn't require much space. Why it is important? Basically, it will provide better cooling, improve reliability, high efficiency, provide compact design, and which will bring a greener future for the power electronics applications. So basically, this work is focusing on both thermal and the power engineering. The solution from both sides are used to provide better technology for everyone. So this is shown in this particular slide. The future scope in this particular slide is shown. It is the ANSYS high-spec simulation is completed, experimental verification is done, and simulation experimental comparison is also done, and which is giving us satisfactory results. Now the next part is that develop a digital twin of the converter for real-time thermal monitoring and extend the approach to actual power electronics applications. In this work we are focusing in EV charging application and contribute to efficient, reliable and sustainable EV e-mobility solutions. So we are committed to bridge the gap between simulation and real world performance to deliver cooling solutions that are practical, reliable and ready for the future. We gratefully acknowledge the financial support provided by the Anusandhan National Research Foundation and the Indian Institute of Technology Mandi for providing excellent research facilities and infrastructure. We sincerely acknowledge our collaborating institutions IIT Bombay, IIT Roorkee and CSIS Siri for their valuable technical discussions. Finally, we thank every member of our research team, Mr. Amit Verma, a MTech student, Mr. Nasim Akhtar, research associate, and Mr. Abhinandan Bhardwaj, a PhD student, for their contributions. Thank you.